we go. Okay. Hi, everybody. I'm Eileen Uchitelle. My Spanish is almost non-existent, so I made this slide so that, well, at least one slide would have some Spanish on it. I'm really excited to be at RubyConf Colombia with you all. Your city, Medellin, is very beautiful, and I'm really glad that the organizers invited me to come this year. I'm a senior systems engineer on GitHub's platform systems team. Basically, my team is responsible for working on external and internal tools for the GitHub application. We work on improving Ruby, Rails, and other open source libraries and how those tools interact with the GitHub application. I'm also the newest member of the Rails core team, which means that I've finally gotten access to the Rails Twitter account. Woohoo! Because we all know that's the most important part of being on Rails core. You can find me on GitHub, Twitter, SpeakerDeck, literally anywhere at the handle Eileen Codes. Feel free to tweet me questions if you don't see me after. I will be here the whole time, but if you don't catch me, tweet me, Instagram me, whatever. Today we're going to talk about the new system testing framework in Rails that I spent 6 months building. We'll take an in-depth look at my process for building system tests, roadblocks that I hit, and what's unique about building a feature for open source. But first, let's travel back in time a few years. Some of you may remember the infamous 2014 RailsConf, where DHH declared that test-driven development was dead. He felt that while TDD had good intentions, it ultimately was used to make people feel bad about how they wrote their code. DHH insisted that we needed to supplement test-driven development with something that motivates programmers to test how their applications function as a whole. In a follow-up blog post titled "TDD is Dead, Long Live Testing," David said, "Today, Rails does nothing to encourage full system tests. There's no default answer in the stack. That's a mistake that we're going to fix." 3 years later, after DHH declared system testing should and would be included in Rails, I'm happy to announce that Rails 5.1 finally makes good on that promise because system tests are now included in the default stack. The newest version of Rails includes Capybara integration to make it possible to run system tests with zero application configuration required. Generating a new scaffold in a Rails 5.1 application will include all of the requirements for system testing without you having to configure anything. It just works. This is probably a good time to address what exactly I mean when I say system test. You may be familiar with Capybara being referred to as acceptance testing. And while system tests use libraries and use the same libraries, the ideology behind system testing in Rails goes deeper than that. The intention of system tests is to test your entire application as a whole entity. This means instead of testing individual pieces or units of your application, you test how those pieces work together. With traditional unit testing, you test that the model has a required name, and then in a separate controller test, you test that the controller detected an error. With unit testing, you're assuming that the view must be displaying the error, but you can't actually test that the user saw it. With system testing, that becomes possible. You can test that when a user leaves out their name when creating their profile, that the appropriate error is actually displayed in the view. System tests also allow you to test your JavaScript and how it interacts with your models, views, and controllers. That's not something that you could do with any other testing framework inside Rails. Before we get into what it took to build system tests, I want to show you what system tests look like in an actual Rails application. When you generate a new Rails 5.1 app, the Gemfile will include Capybara and Selenium WebDriver gems. Capybara is locked to 2.130 and above, so that your app can use some of the new features that we pushed upstream to Capybara, like mini test assertions. In your test directory, a system test helper file called application SystemTestCase will also be generated. This file includes the public API for your Capybara setup for system tests. By default, applications will use the Selenium driver with the Chrome browser and a custom screen size of 1400 by 1400. If your application requires additional setup for Capybara, you can include all of that in this file. Any system test that you write will inherit from application SystemTestCase. Writing an individual system test isn't really that different at all from writing Capybara tests, except for that now all of the URL helpers are automatically included so that you can write post URL and post path without adding any additional configuration. This is a simple test that navigates the post index and then asserts that the H1 selector is present with the text post. Then in your terminal, you can run system tests with bin Rails test system. Rails doesn't run system tests with the whole suite because they are slower than unit tests, and everyone we talk to runs them in a separate CI build. If you want system tests to run with the whole suite, you can create a custom rake task that runs everything together. So let's take a look at system tests in action. I recorded a demo because the tests, I know I just said they're slow, but when you have a very basic app, they run way too fast for me to actually tell you what's happening, so I had to slow it down. So first we're going to write a new test for creating a post. The test first needs to visit the post URL, and then it will click on the new post link, just like a user would who's using your application. Then we can fill in the attributes title with system test demo, and the content attribute with some lorem ipsum. And then we'll click on the create post button, which is just what the user would do, and assert that, well, after we redirect to that page, we'll assert that the system test demo text is present. So run it with Rails test system, and we can see Chrome is booted and the Puma server, and the test just fills it in, just like a user would, and create post, and you're done. And we can see the test pass because there's 2 green little dots. So this looks pretty simple, and this test is obviously not different from Capybara, so what did I spend 6 months working on? There are a few reasons that system tests took a while to become a reality, and then later we're going to look at what the actual implementation on the Rails side is. The first reason that system tests took so long to build is that they needed to inherit from integration tests so they could access the URL helpers, but integration tests were sluggish. Their performance was abysmal. There is no way that the Rails team could push system testing through integration tests without major backlash from the community. Nobody wants their test suite to suddenly go from 5 minutes to 10 minutes, and that kind of performance impact simply isn't acceptable. So speeding up integration tests had to happen before we can implement system tests. In 2014, I worked with Aaron Patterson on speeding up integration test performance. Once we got integration tests to be marginally slower than controller tests, system tests were able to inherit from integration tests. Another reason they took 3 years is that, contrary to what some people think, the Rails core team does not have a secret Rails feature roadmap. Rails is a volunteer effort, so if there isn't someone who's interested in implementing a feature, it's not going to get implemented. Of course, individually, we may have an idea of what we'd like to see in Rails 6, but I'd hardly call it a roadmap. We each work on what we're passionate about, and often features grow out of real problems that we're facing in our applications at work, and system tests are a good example of this. Prior to working at GitHub, I was a programmer at Basecamp. When we were building Basecamp 3, we decided to add system testing through Capybara. And I saw firsthand the amount of work it took to get system testing running in our Rails application using Minitest. This was the major catalyst for getting system tests into Rails 5.1. The work required to get system testing into Basecamp 3 re-inspired the motivation to work on this feature so that others could do less work in their applications and focus on what was really important, writing software. Past August, like not the last August, but the one before that, David asked me if I would be interested in getting Capybara integration into the Rails 5.1 release. Most of my work on Rails had been in the form of performance improvements, refactorings, and bug fixes, so I was really excited to build a brand new feature into the Rails framework. There was just one problem. I'd never used Capybara before. I know that sounds ridiculous, but beyond writing 3 or 4 system tests in Basecamp 3, which I admittedly struggled with, I had never set up an application for Capybara, nor written an entire acceptance test suite. This did have some pros, though. I got to experience firsthand what was difficult about setting up Capybara, especially for a beginner. I had absolutely no assumptions about what was easy or hard when I began development on system tests. Having no experience with Capybara allowed me to see the feature I was building solely from the perspective of what works for Rails and Rails applications. This is not to say that Capybara does anything wrong, but Rails is extremely opinionated in what code should look and feel like. For Rails, it's important that implementing system tests was easy and required little setup, so the programmer can focus on code rather than test configuration. When you're implementing something that you're unfamiliar with, it's best to have a set of guiding principles in order to make your decisions about design and implementation easier. Without these goals, it's easy to get sucked into scope creep and bike shed arguments about details. Having guiding principles means that for any decision you can ask yourself, does my code meet these requirements? For guidance when building system tests, I, of course, use the Rails Doctrine. The Rails Doctrine is a set of 9 pillars that drive all decision-making about all code that goes into Rails. While I was building system tests, I would regularly base decisions on the Rails Doctrine. System tests meet all of these requirements in some way, but I want to take a look at a couple of the principles and how system test infrastructure meets those requirements. The first is optimize for programmer happiness. This pillar is the overarching theme in all of Rails. Rails' entire goal is to make programmers happier, and frankly, I'm very spoiled because of this. Writing Rails makes me happy, and I hope it makes all of you happy too. But you know what didn't make me happy? All of the implementation required to get Capybara running in Rails applications that were using Minitest. The code here is the bare minimum that was required for your application to use Puma, Selenium, and Chrome for system testing with Rails and Minitest. Sure, if you're setting up just rack test, it's 1 line of code, but that's not a good default because you're not really testing your system. RSpec did a lot of this setup for you, but is actually going to be adopting the system test framework when I finally release Rails 5.14, which I need to do next week. Many applications had to do this multiple times to be able to use multiple drivers with their test suite, or had much more setup because they wanted to support different browsers with custom settings. Rails 5.1 system tests mean that you can use Capybara without having to configure anything in your application. Programmer happiness was the driving force behind getting system testing out of your application code and into Rails. You don't need to figure out how to initialize Capybara for a Rails application, how to set a driver, how to pass settings to the browser, or how to change your web server. System tests in Rails abstract away all of that work so that you can focus on writing code that makes you smile. All you need is a simple little method driven by. When you generate a new application in Rails 5.1, a test helper file is generated along with it. If you've upgraded your application, this file will be created when you generate your first system test. All of the code that we looked at previously is contained by this one method. It initializes Capybara for your Rails app, it sets the driver to Selenium, sets the browser to Chrome, and customizes the screen size, and also sets the server to Puma. Rails values being a single system, a monolithic framework, if you will, that addresses the entire problem of building a web application from databases to views to WebSockets and testing. By being an integrated system, Rails reduces duplication and outside dependencies so that you can focus on building your application instead of installing and configuring outside tools. Prior to Rails 5.1, Rails as a whole did not address the need for system tests. By adding this feature, we've made Rails a more robust, complete, and integrated system. As DHH said in 2014, Rails was incomplete when it came to system tests. Rails 5.1 closes that gap by adding Capybara integration. You no longer need to look outside of Rails to add system testing to your applications. Now that we've looked at some of the driving principles behind system testing, let's look at the decisions around implementation and architecture in the Rails framework. We're going to look at why I chose specific configuration defaults and the overall plumbing of system tests in the Rails framework. The first configuration default that I want to talk about is why I chose Selenium for the driver. The barrier to entry for using system tests should be zero setup and be easy for beginners to use. In Capybara, the default driver is RackTest. While it is easy to use, I didn't think it was a good default for system testing because RackTest can't test JavaScript and it can't take screenshots. It's not a good default for someone who's learning how to actually test their system. I also had quite a few folks come into the pull request and tell me they thought Poltergeist was a better default choice because it was faster and it's what they used in their apps. While it is true that it's faster and popular, ultimately I chose Selenium for a few reasons. One of the coolest things about Selenium is that you can actually watch it run in your browser. Poltergeist and Capybara WebKit are headless drivers, which means they don't have a graphical interface. While they will produce screenshots, you can't actually see the tests run, unlike Selenium. Watching Selenium tests run in a real browser like Chrome or Firefox is kind of a magical experience. I mean, until it breaks, but like that first time that it runs is like really cool. I also think that Selenium is a better choice for new programmers, especially those learning Rails and Capybara at the same time. Because you can physically see the test run in the browser, it's easier to figure out what's breaking and what's happening so you can fix it. But the best part about system tests is if you don't like Selenium, the driver options are extremely easy to change. To change the default driver that system tests use, just open your system test helper and change the driven by method from Selenium to Poltergeist. You're going to need to install Phantom.js and add the gem to your Gemfile, but changing the actual driver that you're using is super simple. Rails won't stop you from passing in whatever you want here, but Capybara will only accept Selenium, Poltergeist, Capybara WebKit, and RackTest. Another decision that differs from Capybara's defaults is that Rails uses the Chrome browser with Selenium instead of Firefox by default. Chrome is widely used and has a greater market share than Firefox. In general, I think development is done in Chrome. I do development in Chrome, so it was somewhat of a selfish but also sensible default from that standpoint. But the bigger reason is that while I was building system tests, Firefox was broken with Selenium, and it didn't work with Selenium 2.53. That's since been fixed, but when I started, this was one of the motivations for making the default Chrome, because there was really no way that I could push system tests, like merge system tests into Rails, and be like, oh, by the way, the default configuration is broken. If you want to use Firefox instead of Chrome, simply change the using keyword argument from Chrome to Firefox. Also make sure that your Selenium version is higher than 2.53. The using argument is only used by the Selenium driver, since the other drivers are headless and have no GUI. I'd love in the future to support more browsers like Safari or headless Chrome. Driven by has a few optional arguments that are supported by all of the drivers except for RackTest. The screen size argument sets the browser's max height and width, which is good for testing your website at different browser sizes or setting the size that you want screenshots to be taken at. Driven by also takes an options hash that is passed to the browser's initialization for Selenium or the driver initialization for Poltergeist and Capybara WebKit. This can be useful for passing options that we don't explicitly define in Rails but are accepted by Capybara, like the URL option. One of my favorite features of system tests is they automatically take screenshots when the test fails. This is good for freeze framing failures so that you can see what went wrong. This works with all drivers supported by Capybara except for RackTest. Included in the system test code on the Rails framework side is an after teardown method that takes the screenshot if the test fails and screenshots are supported. And let's take a look at them in action. First, let's change the test that we wrote earlier so that it fails. We can assert that the system test failure screenshots is the text instead of system test demo. And now when we run the test, we'll see that it fails. And if you have like really fancy terminal, you can output the screenshot actually in your terminal. But if you don't, it just outputs a link to the temp file. And so then you can open the screenshot and we can see that system test demo is not the text we were expecting, from Capybara. And so like now you can actually see it and be like, oh, okay, I was expecting system testing, whatever I wrote, failure. And instead I have system test demo. So you have to change that test. One of the less obvious features of system tests is that database cleaner is no longer required. Those of you who've worked with Capybara before will know that transactions during Rails test runs with Capybara wouldn't get properly rolled back. It has been the status quo for many years that Active Record was just broken and unable to roll back transactions when tests were threaded. The basic gist of the problem was when a test was started, Rails testing code would start a transaction on a database connection. And then the web server would open a second connection to the database on a separate thread. When the test runs, database inserts or updates will happen on the second thread instead of the thread with the transaction. When the test finishes, inserted or updated records won't be rolled back because the fixture thread cannot see the web server thread. If inserted or changed records aren't rolled back at the end of the test, subsequent test runs will fail due to uniqueness constraints or other issues with leftover data. I spent a long time in those 6 months building system tests trying to solve just this problem. It took me a while to understand the real issue with Active Record, and I was also surprised at how many years other users had just accepted that this was broken in Rails. So I wanted to solve it so that we didn't need to force users to use yet another dependency by default. The problem was I didn't really know how to fix it. And I'm going to be honest that concurrency is not one of my strengths. So I had to ask for help from the two people who know more about concurrency and Active Record than I do, Aaron Patterson and Matthew Draper. The problem was that Aaron and Matthew had differing opinions on how to fix the problem. I first tried to fix it Aaron's way, which was to tell Active Record to check the connections back in when they were done with them. This broke a whole bunch of Active Record tests because you can't check a connection back in while the transaction's open. So this was actually a very bad way to fix it because it didn't actually know that it wasn't actually done with the connection, so you can't check it back in. So luckily Matthew came up with a different solution. So Matthew and I changed Active Record to force all of the threads to use the same connection in the test environment. So when the test starts a transaction and a database connection is opened, the Puma server then will be forced to connect to the database on the already existing thread instead of creating a new one. That way, all of the database inserts and updates happen on the same connection as the original test transaction. All of the data will be rolled back when the original test transaction is closed. Without Matthew and Aaron's help, I would have had a much harder time figuring out this problem, so I'm very grateful to them. Okay, so we spent a lot of time looking at individual settings and the public API for system tests. So it's time to take a look at the plumbing that makes all of this work. None of the code that we look at here you should ever have to touch. This is just everything that was abstracted away by Rails so that you don't have to worry about configuration and instead can focus on writing your tests. System tests in Rails live in ActionPack under the ActionDispatch namespace and inherit from integration tests so you can use all of the URL helpers already implemented on the integration side. This entire class can't fit on the slide, so I'm going to go through the methods as they're called by your test when you run it. When you run a system test, start application is called first. This boots the app and starts the Puma server. Your system test helper file then calls the driven by method. This is where the default configuration settings are implemented. When driven by is called by system testing driver, when this is called a new system testing driver class is initialized with the arguments that you passed in. The driver object is initialized with name, browser, screen size, and options. The browser argument is only used by Selenium. The running test is then initialized. It's important to call use on the driver initialization. I cannot say that word. So that the driver is set when the individual test classes are initialized. This allows you to define multiple drivers per test suite. Because of this line, you can use Selenium in one superclass and Poltergeist in another. The use method calls register if the driver is not racktest. Racktest has no option, so we simply go straight to setting the driver in Capybara. Register is a case statement that registers the appropriate driver. And the register Selenium method is how Capybara sets the browser to Chrome with the options and screen size that we passed in. And finally, the use method calls setup, which simply sets the current driver method in Capybara to the driver you passed into driven by. This is the basic plumbing required in Rails for system testing. It's relatively simple, but I'm really happy that applications don't have to do any of this work anymore. So one of the things that struck me about working on this feature for Rails was how different it was from building features for a product or client. I think this is in part because open source work is extremely public versus client or product work is usually a secret until the big reveal. Probably thinking that, duh, it's open source and by virtue public. But almost all of the work that I'd done previously was related to performance improvements, refactorings, and bug fixes. This just isn't things that folks come out of the woodwork to comment on. This isn't the type of work that people care a lot about when it comes to style or implementation. It doesn't change their application unless you're touching the public API. But adding a brand new testing framework, that's something that everyone had an opinion about. In the 3 months that the system test pull request was open, I got 11 reviews and 161 comments. And this highlighted one of the big challenges of open source for me, that it's really difficult to not constantly feel like you're being judged. Doing open source work makes you extremely vulnerable. It can feel like every comment, every commit, and every code change that you make is open to public scrutiny. And this is one of the hardest things about working on open source, and it's one of the things that I think keeps newcomers from contributing. I'm on the Rails core team, and I still get an adrenaline rush when I push to master. I still start sweating if the build fails after I merge a pull request. I've been doing open source for many years, and I still feel vulnerable. It's difficult to remain confident and keep your cool when doing publicly visible work. I often had to fight the urge to just rage quit all of it because I was tired of debating the choices I had made. Even if the other person's right, it's exhausting to feel like you're having the same conversations over and over and over again about implementation. But really, public debate is an inherent part of open source, and you're always going to have to argue for your position. So when your confidence is shaken, it can be tempting to look for ways to find consensus among everyone who's reviewing your work. When the desire to find consensus is not unique to open source. What's unique to open source is the stakeholders that you're trying to find consensus with have varying levels of investment in the end result. When you're building a feature for the company that you work for or a client, you know who your stakeholders are. Those are the people who care most about the feature that you're working on. But with open source, you don't really know who's going to be invested until you open that pull request. Of course, I knew the Rails team was a stakeholder and cared a lot about how system test was implemented. And I knew the Capybara team cared about the feature as well. But what I wasn't prepared for was all of the other people who I didn't know who would care. And of course, caring is good. I got a lot of honest and productive feedback from community members, and system tests are better because of that feedback. But it's also really overwhelming to feel like I needed to debate everyone who had varying levels of investment. Rails ideologies of simplicity differ a lot from Capybara's ideologies of lots of features, and all of the individuals who were interested in the feature had varying opinions as well. Which driver was the best default? Was it okay to change Capybara's long-time defaults from rack test to Selenium? Was it even desirable to include screenshots? What should the API look like? What should the name be? I struggled with how to respect everyone's opinions while building system tests, but also maintaining my sense of ownership. I knew that if I tried to please all three groups and build system tests by consensus, I'd end up pleasing no one. Everybody would end up unhappy because consensus is the enemy of vision. Sure, you end up adding everything that everyone wanted, but the feature loses focus and the code loses style, and you lose everything that you ever felt was important. I needed to figure out a way to respect everyone's opinions without making system tests a hodgepodge of ideologies and feeling like I threw out everything that I cared about. I had to remind myself that we all have one goal: to integrate system testing into Rails. Even if we disagreed about the implementation, this was our common ground. With this in mind, there are a few ways to keep your sanity while dealing with multiple ideologies in the open source world. The biggest thing is to manage expectations. In open source, there are no contracts. You can't hold anyone else accountable except for yourself. And on top of that, no one else is going to hold you accountable either. You're your boss and your employee. You're the person who has to own the scope. You're also the person who has to say no. There were a ton of extra suggested features for system tests that I'd love to see, but if I had tried to implement them, system tests still wouldn't be in Rails today. I had to manage the scope and expectations of everyone involved to keep the project in budget. While I greatly respected everyone's opinions on system tests, ultimately I was building the feature for Rails. System tests needed to fit into Rails look and feel. To do that, I had to work with Capybara's ideologies, that acceptance testing should be robust and have many, many options. There's nothing wrong with this approach, but it doesn't follow the Rails Doctrine. Capybara wasn't providing a clear enough path for getting system tests into your application. In the end, it was the Rails team who was going to decide when system tests were mergeable, so I decided that I was building the feature first for Rails and I'd honor their principles first, and then second everyone else's. When you're building open source features, you're building something for others. If you're open to suggestions, the feature might change for the better. Even if you don't think you'll agree, you have to be open to listening to the other side of things. And it's really easy to get cagey about the code that you work so hard to write. I still have to fight the urge to protect system tests code that's written in Rails because I wrote it and I put a lot of time and effort into it, so I'm protective of how it looks and feels and develops. But I also have to remember that it's not mine and never was mine. It belongs to everyone who uses Rails, so I need to be open to suggestions, tweaks, and changes. Which brings me to my last point. Open source doesn't work without contributors. A perfect example of this is I merged system tests before I knew they were 100% stable. I merged them when I knew they were bugs. I did this because I didn't know how to fix those bugs, like displaying the correct number of assertions or how to run system tests separately from Rails test. And the best part about this was that the open source system worked. When you work for a client, you can't push unfinished project live and be like, hey client, improve this work. But with open source, you can build a foundation for others to work off of. I didn't merge system tests with known issues because I was lazy. I did it because I knew that that contributors in the community could help me fix the problems when they tested them in a real application. And by the time the Rails team released the RC1 of Rails 5.1, which was less than a month after the first beta, all of the issues that I knew about before merging had been fixed by other contributors. Capybara's maintainer added mini-test assertions to Capybara. Previously, users who were running system tests with mini-test would see an incorrect number of assertions because Capybara was handling those the RSpec way. This is one of the things that I had no idea how to fix, so I'm so happy that Truffle took the time to push this upstream, and this change is a huge win for system test. Robin 850 sent a pull request that changed system tests so they don't run the whole suite. We didn't want system tests to run when you run Rails tests in your application because system tests can be slow, and I'm really happy that he fixed that. These two contributors help make changes to driven by so it could be used on a per subclass basis rather than globally. When I originally designed system tests, it was intended to be a global setting because I assumed that if you wanted multiple drivers, you would just be like a power user of Capybara. But once system tests were merged, it became clear that others wanted to use driven by for multiple drivers. So I'm glad that these two contributors help make system tests more robust. And RenChap help improve screenshots to make them configurable and display differently based on environment settings. This is the reason that you're able to display the screenshot in your terminal, because he worked on this. This was also his first contribution to the Rails framework, which I think is really awesome. And all of these improvements to system tests highlight the real beauty of open source. It doesn't work without contributors, and it doesn't work without you. Open source is for everyone, by anyone. Contributing to open source isn't easy, especially a mature framework like Rails. But Rails has an astounding past and a bright future because of all of the contributors that care. Don't believe anyone who says Rails is dying because, frankly, the future has never been brighter. Every day I see brand new contributors coming in and improving the framework. And Rails can and will benefit from your contributions in the future. Just like the contributors who push changes to system tests, you too can make system tests and Rails better. By contributing, you help define Rails' future. I hope that you enjoyed learning about how system tests work and my process for writing the feature, but most of all, I hope that I inspired you to contribute to open source and especially Rails in the future. Thank you.